Today's problem is max sum increasing subsequence. I guess I can't scoot that over anymore. Okay. Difficulty is medium. Given an array of positive integers, find the maximum sum of a subsequence such that the elements of the subsequence form a strictly increasing sequence. In other words, among all strictly increasing subsequences of the array, return the one with the largest possible sum. Okay. So again, a subsequence is not like a subarray where the numbers have to be contiguous. A subsequence is just, a set of numbers that are in order in the array. They may not be consecutive numbers, but that still counts as a subsequence. So you can see that in this first example. The max is 1, 2, 3, 100. Note that those are not a subarray. They're not consecutive, but they do form a subsequence. So, next example, 4, 1, 2, 3. We can't take the 4 there, so we're going to take the 1, 2, and 3. That'll make 6. I'm not sure why... I'm not sure why we need 2 examples that are like almost exactly the same, but in this one, again, the max is going to be 1, 2, 4. That's 7. Array size will be between 1 and 10 to the third, 1,000. The numbers will be between 1 and 10 to the fifth, 100,000. Expected complexities n log n. I have to think about that for a second. N log n. So we do that. I don't know. I thought it seemed like n squared to me, but okay, n log n. Auxiliary space, O of n, for a DP array. Topic tags, dynamic programming. All right, I got to scoot this over a little bit so we can see it. Which example? I guess we can do the first example. We can do a walkthrough of the first example. So a little bit of overhead here. We've got n, which is the length of the array. We've got a dynamic programming array. We're going to initialize the dynamic programming array with the initial array elements. And actually, let me pause this a second and draw that. All right, so here's our DP array, and we're going to initialize it to the elements of the initial array, because what the DP array represents in this problem is the maximum sum of increasing subsequence ending at each index. All right, so to start with, the only thing that we know is that for each index, there is a one-element subsequence, and the value of that subsequence, or you could say the sum of that subsequence, is just whatever the element is at that index. And then we'll build it up from there. So we start with I equals 1, and we're going to go through the array from, and that would be right here. We're going to go through the rest of the array, and as we do that, we're going to look back at previous elements and see if we can find smaller elements. Because if we can find smaller elements, then we can use the larger element to extend the increasing subsequence. Okay, so we'll start with 1. J would be equal to 0. In that case, is is 101 greater than 1? Yes. All right, so DP at 1 is going to equal the max of 101 or 1 plus 101, which would be 102. Normally I could probably make that 1 into a 2, but I squeezed it in there too tight, so let's make it 102 like this. 102. All right. So we're done with that. Moving on to the next element. That is at index 2. We'll go to j equals 0 again. Is 2 greater than 1? Yes. So dp at 2 is going to be the max of 2 or 1 plus 2, which would be 3. Okay. Good, because that actually is the maximum subsequence that we could get ending at 2. 1 plus 2, that would be 3. Is 2 greater than 101? It's not. So we go to the next index, which is 3. All right, so now we're here. Okay, going back to j equals 0. Is 3 greater than 1? Yes. So dp at 3 is going to be the max of 3 or 1 plus 3, which is 4. All right, so let's get rid of that and put a 4 there. Okay. Is 3 greater than 101? No. Is 3 greater than 2? Yes. In that case, dp at 3 is going to equal the max of 4 or 3 plus array at I, which is also 3. So that would be 6. All right, put that in. 6. Okay, that's good. Let's see, 6. That is the maximum subsequence there, increasing subsequence, I should say. 1, 2, 3. Okay, so we got 6. And finally, we will go to 4. So now we're here. Is 100, and j starts over at 0, is 100 greater than 1? Yes. dp at 4 will be the maximum of 100 or 1 plus 100, which would be 101. All right, let's fix that. And that is, I need to erase that line. That is 101. All right. Next number, 101. Is 100 greater than 101? No. Is 100 greater than 2? Yes. So dp at 4 would be the max of 101 or 3 plus 100. Okay, yeah, that's bigger. So now we're up to 103. Okay, take that out. And we've got 103. And finally, is 100 greater than 3? Yes. So dp at I is the max of 103 or 6 plus 100. That's the max, 6 plus 100. So let's put that in. Okay, 106. All right, so that's the process of building up the DP array. Initialize it to the original element of the input array, and then starting from index 1, look backwards in the array for smaller elements. And if you can find smaller elements, you can use those to extend, you can use those to extend the increasing subsequence. And that is, that's it. We should probably try to run it. Let me get rid of that, and let me actually scoot this over again. And point out that that is in fact the answer that we were looking for is 106. Well, you can tell that from looking at it. All right. So running this. All right. That is longest something. What is that called? Max Sum Increasing Subsequence. I hope you will like the video, give the video a like. You can subscribe to the channel, subscribe to notifications, and we'll see you next time.